Hi ladies, so I'm just going to work through another electrolysis question. Now I'm going to have to use my laptop to show you this question because my papers only go back so far. So it's a 2005 question. We can see there's a Hoffman voltameter there, so it's going to be about the electrolysis of water. So it's going to ask us first of all to define oxidation in terms of change of oxidation number. Very similar questions to the last time. What is observed when chlorine gases bubble through an aqueous solution of sodium bromide? So that is a halogen displacement experiment. Okay, we'll talk about that in a second. Explain your answer in terms of oxidation reduction. So a solution of acidified water is electrolyzed by passing an electric current through it using inert electrodes. Which electrode A or B does oxidation occur and which species is oxidized? And write a balanced half equation for the oxidation reaction. Okay, so that's the reaction that's going to occur at the anode. So let's start off with your oxidation number and change your oxidation in terms of oxidation number. Okay, so so it's 2005 question. I'm actually not sure what question, sorry guys, I'm using study clicks. Okay, so part A. Okay, so oxidation in terms of oxidation number. Now if they said in terms of electron loss or gain, girls, you would say oxidation is the loss of electron, reduction is the gain of electrons. Okay, but they haven't asked you that. They've asked you in terms of oxidation number. Okay, so oxidation means the oxidation number will increase. Does that make sense? Okay, so oxidation means the oxidation number will increase. Reduction means the oxidation number would reduce, and reduction obviously would be the gain in electrons. Okay, so there's two different ways that they can ask you about oxidation reduction in terms of definitions. Next question. What is observed when chlorine gases bubble through an aqueous solution of sodium bromide? Okay, so sodium bromide, so that's NaBr plus Cl2. Okay, so what happens here? Now, if we look at the periodic table, girls, here, okay, we'll see that chlorine is above bromine in the halogens, okay? And that means that chlorine will come along and replace bromine in any compound, all right? Just like chlorine will come along and replace iodine, or chlorine will come along and replace that astatine. I've never used that one before. Okay, so fluorine is the most electronegative. Okay, it's one that's most reactive. It'll come in and replace all of these guys underneath it. Okay, now if we were going to to react chlorine with sodium fluoride, that wouldn't work because fluorine it's more reactive, has a greater hold on the sodium. Okay, so it only works when you're reacting things that are below them in the halogens. Okay, so let's have a little look at this. So NaBr. Okay, so what's going to happen here, girls, is you end up getting NaCl, which is your sodium chloride salt, plus bromine, Br2. Okay, NaCl plus Br2. So it wants to know what's happening in terms of oxidation what's happening in terms of oxidation and reduction, and also wants to know what's observed. So what do you see happening when this occurs? Now, so what you have is you have a clear solution, okay, and you get the formation of a brown color forming. Okay, so brown color, brown solution occurring, because bromine is brown in colour. Okay, so that is essentially what's happening during that experiment. Okay, you get the formation of a brown colour, which shows the formation of bromine. Now in terms of oxidation reduction, let's see if we can work that out here. So chlorine's all in its own yo. Okay, so its oxidation number is going to be 0. Okay, bromine is also on its own yo, so it's also going to be 0. Okay, the other two slightly a little bit more complicated. All right, so sodium we know is in group 1, so it's going to be +1. Bromine's in group 7, -1. Easy peasy. Okay, sodium here is going to be +1. Chlorine here is going to be -1 because it's in group 7. So sodium, there's no change in sodium. Okay, so we can leave sodium out of there. Okay, so sodium always stays +1, but bromine and chlorine are changing. So bromine's going from -1 to 0, and chlorine is going from 0 to -1. Okay, so remember, let's see if this is oxidation or reduction. -1 to 0, the number is going up, isn't it? So this is oxidation. It's losing an electron. Okay, 0 to -1, it's gaining electron, that's reduction. Okay, so that's that question answered. You were saying what you're observing occurring, which is your brown colour forming. You're saying that chlorine is coming in and replacing bromine because it's more electronegative, it's higher in the halogens. And then you're saying what's being oxidised and what's reduced. There's quite a lot in that bit of question there, okay? Next part, part 3. Now they're asking you about the electrolysis of water. So a solution of acidified water, which was dilute with sulfuric acid, is electrolyzed by passing electric current through it using inert electrodes. At which electrode, A or B, does oxidation occur? Now let's have another look at this question here. Now, something we didn't talk about, girls, is how do you know which is the positive anode, which is positive electrode, and which is the negative electrode, okay? Now, this is a little bit of junior cert science here, okay? So the long one here, see the way there's a long line there? That means this is the positive side of the power source, and then the small side there is the negative side of the power source. So this one here, A, is your positive electrode, okay? So long side positive, short side negative, okay? So A is your positive electrode, okay? Okay, so yeah, so your answer here, girls, is so which electrodes which electrodes oxidation occur? So oxidation occurs at the anode. Remember, that is your positive electrode. Okay, remember oxidation is a loss of electrons, okay? So oxidation, this is electrode A in the diagram. Okay, so this is electrode A. Alright, then it asks you which species is oxidized, okay? Now this is where you look at your half equations again. So remember, there's 2 ways we can do the half equations in for water, the splitting water. So you need to just take one and learn one off. So the thing that's being oxidized, so water is being oxidized. Okay, so the 2 ways that you can draw the half equations for your anode here, girls, is the following. So you can have this one, 2OH minus, arrow O2 plus 2H plus 2E minus. Okay, so the electrons are being lost there, okay? Or you can draw it like this, 2H2O, arrow O2 plus 4H plus 4E minus, okay? So it's up to you which one of those you put in, but that's the full question done there. So I'm hoping that is clear to you. Thanks, girls.